Okay, I think we could start. Okay, so welcome everybody. My name is Haptuoldu. I'm a co-founder and CEO of Inteca, and I'm joined by Marek Martoffel from Red Hat today. And today we're gonna share our story regarding leveraging AI in our delivery processes. We want to tell you our story, and we want to also discuss how Red Hat technologies are supporting things we do, and Mark is going to take over after me. I will start with my presentation, which will take about 40 minutes, and then I'll pass to Marek to tell more about the technology behind what we're going to talk about today. So I guess it's good to start now. I'm going to show the presentation now. And I should share the screen. Okay, I hope it's visible now. All right, so what we want to talk about today is our journey of Inteca on leveraging, building, using AI in our operational work, and what we've been working on since last 2 years. And before I start, I would like to just quickly tell you more about who we are. We are basically a company that builds software for our customers, and mostly for enterprises. So specifically in financial industry, like banks, insurance companies, and other financial companies. We also have customers in other industries as well. Except of building software, we also assist our customers in improving their software delivery lifecycle, specifically in DevOps area, also in architecture, and also requirements analysis through the whole process of getting things done from initial problem to actually working solution on production. So that's briefly about us. So what I want to talk today is to tell you a little bit of our history for the last 2 years, and what we've been working on for last 2 years. And it all started like in 2023. And 2023, specifically the second half, was like the big AI hype in Europe, actually AI getting a lot of traction. And that was the time when we actually start asking ourselves the question, this big new thing, technology is here. What should be our future? Should we care? Should we start working, thinking about it? Should we start using it? And what could actually be done with this technology? And should we transform the way we work? And actually, was also the question: are we actually on the verge of actually market revolution, something big? So the reason we start thinking about it is that if you look at things we do, I would say the classic software engineering, you can easily understand that there is a process of translating intent, consumer intent, customer intent, user intent, which is always at the beginning of the process. And what we do, we take this intent and basically produce source code that we then build and ship and put into production. And this delivers functionalities that actually cover the problem, which is behind this intent. So solve the problem, deliver feature. So and that's actually what we do as a company, as engineers, and that's called software engineering. So if you look at the evolution of software engineering, if you look at what is available today, we have this big thing, AI, called large language models, and they are actually quite good at understanding the intent. So you may think of, well, if they can actually understand Intent and answer questions, the questions can actually produce code and produce features, so do the software engineering part. And of course, today the answer is quite obvious, because we have a big wave of what is called vibe coding or agentic coding. So today everybody's experimenting in that area, but like at least 2 years ago, 1.5 years ago, it was not so obvious. So what we did, we asked ourselves the question, well, what if we could automate our full software delivery process, like make it 100% done by AI? Is it actually possible? Making AI work, of course, under human supervision, but basically do the whole thing, from intent to working functionalities. So the problem in our case was that if you look at our process, producing the source code, so basically making AI produce the source code, I would say is just a part of the big picture. It's a part of the process. Since we work with enterprise customers, it all starts very early in basically problem definition. So on the way, you need to actually solve several problems on the way until you get to the software, to the source code. So there is like requirements analysis part. You need to understand these requirements. You need to put it in the context. So there are like, enterprises run a lot of applications, systems, like dozens or hundreds of applications. So solution architecture needs to be designed in a proper way, taking into consideration what's already in the organization, or what needs to be built or extended. Then you go into design phase, where actually you make it more detailed designs of the newly developed features or changed features, and then you go into implementation. You need to quality assure, and then of course the deployment and maintaining. And there are many challenges on the way. You need to make sure the features, the requirements are put in the right context. So the architecture, what I already mentioned. There are standards. Enterprise have standards for CI/CD, code quality, security, and you need to provide a proper level of documentation. Specifically, financial sector is quite since it's regulated. You need to also maintain knowledge about what you're changing and change management process. And of course, the main challenge was, how do you make it repeatable? If you have any experience with AI, with like ChatGPT, you know that if you put the same question twice, you may get different answers, let's say modified answers each time. It's not like deterministic technology, like it always replies in the same way. So that was one of the main challenges at the beginning. So of course, there is also a context where architecture of our customers are not simple. They are like complex environments. And often the project involves many teams, sometimes many vendors. So getting this vision into, I would say, reality was not that easy task, like when we started. So fast forward to today, that time we basically thought, well, if we just replicate the way we work and make AI replicate our teams, the roles in the teams, and make it like agentic teams. AI is actually put into different roles to solve all of the problems I already mentioned. If we could just replicate this process and try to run it and see what comes out. So fast forward to today, the way it looks today is, if we could just, the process we run today is, we start with the feature, with the description of the intent. So often it's a customer documentation, listing business requirements. We have this set of agents. I'll just rewind it. We have this set of agents which are coordinated by what we call the coordinator. The documents gets in, it gets translated it gets understood, and then the requirements agent kicks in and he starts building the requirements model out of the input documentation. So basically tries to put a structure into something which was sent provided by customer, or by users who actually require some systems, some functionality to be built. And the workflow starts, and the coordinator is basically making sure the workflow goes according to the plan and to the practice which is built in and configured. So the requirements model is built, and then we move into analysis phase, and you have solution architect. So the system analyst agent who actually takes the requirements and tries to build the initial requirements model. So what you're seeing here is actually the agent is executing the set of tasks and working in a tool, and it's building the domain model. On the left-hand side, you see the tasks, and it traverses through the tasks, completing each task, and then provides the initial domain model. And now the last part of this step is actually getting the user feedback. So this screencast shows actually what user sees on his screen, where actually on the left side you have the workflow and the task. On the right hand side you have actual tool, and the initial domain model is passed through for initial feedback. And then once the feedback is done, the workflow continues to the next steps, where actually this domain model is further fine-grained and validated against actual requirements. And there are many steps. Sometimes it's iterative. When some bugs are found, it gets back to the previous step to correct it. Also, the user may steer with his feedback some of the steps, and basically it works like in a loop until the final outcome is validated. So the next stage is solution architecture. So once the initial domain model is there, the solution architect agent kicks in, and it has a set of tasks. First of the task is to actually understand what is already available in the context of given requirements. So it scans a repository for systems which are existing, and then select candidate use cases. So to understand whether we could use any APIs, functionalities which are already there, and which of the APIs are actually for reuse. And then it builds what we call system context diagram. This is just the screencast shows just the first part. So the initial system context diagram, which is like high-level view of what the design system is going to how it's going to integrate with other systems, and what APIs, what interface is going to use. So this initial model is passed for human review, and then once it's approved, the second level, I would say, the components of the application are being designed, but it's still high-level design. It is not code yet. It's not detailed design of interactions. It's just solution architecture review. This stage is basically forms the context for specifying the detailed features. And then this is where system analyst gets back to work, and it starts to basically build functional documentation, which is like specifying features in terms of use cases. In here, we use use cases. This is one of the practice we use, use case-driven analysis. So use case scenarios are being built. They're of course validated. There are like validation steps, but we don't show it here because this is like a loop of validations. And then the mockup designer, the agent, which is in a role of functional mockup designer, starts to design user interfaces. These are functional mockups. These are not UX yet, but the whole idea is what you see on the left side. The functionalities are being designed, and human can actually see and approve it. And then we produce the specification. This is a set of documents in form of markdown, and actually this is where the CI/CD part starts to. We actually initiate the CI/CD part here because it lives in Git. Starts to live in Git, and then the first product increment is actually already put into documentation, and what we call high-level design. And then the next stage, it's passed to the next stage, where actually the development agentic team is starting. Development agentic team starts to develop starts to develop the features. But of course, the implementation is before we start implementation, there is an agent called designer who actually produces detailed design of functionality, which means all of the flows, the internal components are being designed and also put as a driving specification for implementation. And once this detailed specification is produced, the implementation starts, and the agents are actually developing the features, the back end, the front end, automated tests are being developed, and end-to-end tests are also being developed, and the features are ready for human review. So basically, once all of the tests pass, the functionalities are passed to are deployed to environment, and then we could actually validate it. Humans can actually validate it. So this is the process we run in some of our projects on production today. Actually, our teams work with agentic teams in this way. So what we achieved and what we could observe in these areas is actually that most of the code is actually developed by AI today. Like more than 90% of code is produced by AI. What we also could achieve is that the specs are produced by AI, and for most experienced team members and teams, we could actually cut the feature development by 80%, which is like really significant amount. Of course, there are team members who are onboarded and teams who are actually starting to learn this technology, and these figures are lower for them, of course. But what is also a benefit here is that we are getting 100% of test coverage with this method, because it turns out that AI, when configured appropriately and having a good specification, can really build good tests and write good test scenarios and automated tests. So this is the figures. These are the figures that we see today. And what is interesting is the problems we had to solve on our way. So one of the main problems was repeatability. I already mentioned that if you talk to AI on ChatGPT or any other LLM, you see that basically you may not expect similar results when asking the same question, and that was a big thing to solve. And there are ways to do it. You need to actually guide AI in certain way, giving clear instructions and checklists and fine-grained tasks, and then basically also tests that validate if the output and outcome is according to the standards. The adaptability was key feature. So you need to have a way to adjust the workflow. So humans who work with agents need to have a way to quickly and easily adjust the workflow and test if it passes once it's been fixed or the step was fixed. So what we also noticed is that not all LLMs are actually good at everything. So first of all, if you look at these most powerful models, most powerful models from OpenAI or Claude, they are like very good at certain things. We call it, I would say, thinking part, planning part. But then once it works for you, you would like to search for optimizations. So pass some of the tasks to less powerful models to save time and cost, because they are quicker, they respond quicker, and they are cheaper to run. So this is the idea. You need to be able to actually have multiple LLMs or models, I would say, to optimize your flow. And of course, the one of the main parts was how to design the workflow, how to split it into manageable pieces, because well, the thing is, the AI LLMs have limited capabilities in terms of the context they have. So context is key. This is the last point here. If you try to do it practically, you see that there is like 100 kilobytes, 150 kilobytes of limit where actually they are effective. Then you see this. There is a notion of context rot, where actually tasks that are contexts which are like larger are getting really bad results, and you need to be able to fit any of your problems into this context window. And that actually determines how you design your practice, your workflow, and that's very important. And of course, passing the state between the workflow stages is also very important. You may think of AI agent that it wakes up every time and has no context and no memory what has been done, and no state what has been done before, or what was done in previous step. So you need to have a way to actually put him in the context for making him do the task in an appropriate way. That's also a key challenge. So when we start thinking about it, we need to come up. The problems were kind of repeatable, so we need to come up with a method how to actually define the problems and how to address them in a systematic way. And then we started to look for references in standards in how actually people work, and we look for various standards which are available, and then try to adapt them into actually the agentic work. So we came up with the concept of practice. And so we said, well, what is a practice? A practice is a set of activities that are performed by a team, and they basically, at the end of the day, they produce work products which are composed of core elements. So think of a requirement. Requirement from the customer is like a core element. You start with some idea, some intent, and then what you do next, you actually specify it in details. So you put another core element, like a domain entity, and then you have maybe a use case, maybe a user story. So these things are interrelated, and they have connections. And then, of course, you close it in work products, something that is being produced, either it's a file or it's a part of the model, and then agents are actually producing that. And you need to have the checklist for each of these small things to check whether it's actually meeting the criteria, which is meeting the standard, but whether the work was done correctly. And of course, like people need tools, agents also need tools to be able to operate on these work products, like access to file system, access to any other systems, like changing the file, changing the system data, etc. And then at the end of the day, you have the competences. Some of the frameworks which are already on the market call it skills, but basically we think about what is the configuration of the agent in terms of what he could do and understand. And well, you need to make agents competent in terms of what they understand and know in relation to a task. So this is also a concept of how do you configure the agents and make them work in the workflow. So today, if you look at, getting back to the picture, if you look at this classical software engineering, the way we think about it in Inteca is that, well, if you have an AI and you have the intent, we are shifting from classical software engineering to a domain where actually you put appropriate set of instructions and context and a workflow for AI, and you basically make it work with this context instructions workflow along with people to convert the intent into working functionalities. And the shift is called practice engineering. This is what we call. So instead of thinking just about, well, how do we produce software, we start to think, how do we make AI convert intent into functionalities under our supervision as humans, because still this is all for humans. Intent is coming from humans, and these functionalities are for humans, right? So, and this is what we call practice engineering. So we define it in a way that, well, it's a discipline of designing the orchestration of work between AI agents and humans to automate and continuously improve repeatable ways of working, so that organizations can actually leverage the AI and AI potential and make it work in a scalable and adaptive manner. And we think this is like a big shift in terms of thinking about the roles of today's software engineers, people who are responsible for translating intent to working functionalities. And this, I think, also changes the way we think about this profession and in this industry. So what are our observations? First of all, this is like a paradigm shift. Like we had these experiences, our developers when we're running these workflows, they had like, sometimes they wanted to modify some pieces of code and write some of the code themselves. And then it turned out that once the AI was run on top of these changes done manually by a person, it didn't actually understand that. So it's like people were interfering with something which was done by AI, and AI couldn't understand that. So the new approach is, if the AI doesn't actually produce what you need, what you want, what you should probably do is change the practice, change the description of the task for AI to make it work in a proper way. So that's actually the paradigm shift. That's the change of thinking. So it's like more like managing a team of agents than actually building the artifacts by your own. There is this thinker, worker, and doer, checker pattern. Like you would like to use the powerful models for thinking tasks, like all of these design tasks, checks, and the worker models, so simpler, faster models for doing the repeatable work according to the specs you provide. The doer, checker, so each of the tasks should be split into two phases. One is do the job, and second one is actually check if the job is done correctly. You also need to separate the context here, so that the agent that starts checking has a fresh start, just looks at the artifact and validates if they are correct according to the standards and checklists. Throughput. What we observe is, well, since our higher velocity internally, this is nice outcome. We're quicker, faster to deliver, but at the end of the day, it's still end-to-end for if we are end-to-end with our customers. So we build something for them. In order for them to have benefits from that, we need to actually optimize the full flow. Today, we still need to wait for them for their stages. Like we ship code faster, but still wait for like official QA phases at the customer side, deployment, etc., etc. So in order for this approach to bring value for our customers, we understand that we need to actually transform the entire value chain together with our customers. And also, it's also the reason why we're actually getting PractIQ public, and we want to introduce it to our customers, because this is the way we see the true value could be built for customers. The cognitive load. Well, that was one of the main challenges. Like if you have a classics engineering, like developers build code, write code, they do it incrementally. So basically, write something, test, deploy, test, and do it in loops. In this approach, AI is producing massive amounts of changes, and basically the code reviews or any quality reviews, people need to actually scan a lot of I would say documents or files or changes, and that's basically makes our engineers well, this could be well, there's a cognitive load involved. So what we work on now is a new pattern, like adjust the practice to a level where you don't have to read everything, and make sure the agents, I would say, check themselves in a way. and trust what is being produced. So make it repeatable, right? Employee satisfaction. This is also one of the interesting observations. So what we observe is if you have developers who are responsible, who work in a like classic way, in some of our organizations, developers just get tasks in Jira or any other tool, and they get task description and they start coding. So all of the design work, all of the customer work with customer, like designing workshops, that is done by, for instance, analysts or tech lead. So developers in this role tend to have really large satisfaction drop because basically now the task of just coding is being replaced by AI. So what we also observed is in order to gain efficiency and gain this velocity, developers need to come early in the process. So basically start working on the use case level to understand what are the requirements, and then basically make sure, read the specification being produced, adjust it if possible, making feedback to the AI, and then be able to actually understand what is being built. So there is a shift of responsibility of software developers. They are getting earlier in the process, and I think it's like shift towards more analysis and design part or architecture part. So and then what we see is actually the actual satisfaction when this shift happens is that the AI solves a lot of things which are not really fun, like writing tests or writing plumbing code, etc. And people who actually work in this design part, they are working in the they're working on the business logic and on the problem part, and that's really fun. But this is actually also a shift in a classical developer role that we observed. So at the end of the day, today at Inteca, what we say is we call it practice engineering, and there is a need for end-to-end builders, people who practice engineering skills. So people who actually work on understanding the problem of the customer and adjusting the practice, adjusting the AI agentic team to actually complete the work. And that's why we call it practice engineers. And actually the source code itself just becomes a byproduct of this process. And I think it's like a quite interesting shift in the whole approach. Just to finalize before I finish, I just want to briefly discuss what is PractIQ architecture today. This is what it's composed of. So you have these AI models, and we use these public available models mainly, either hosted on cloud, like native clouds, native services of their own, or in the cloud, like Microsoft Azure or AWS. And these are like the main brains we use. And the platform itself is like, we have human interaction layer, which is mainly Visual Studio Code and extensions we built for it. And there is a web interface, so you can run it. You can actually run it in your browser, specifically for the early parts I've shown, like analysis, the solution architecture, etc., or just business requirements definition. And there is a practice repository, which is like a set of pre-configured practice we've built. And the whole idea is it should be easy to build new practices or extend practices. So this is actually the extendable part. And the whole idea is that we need to be able to adjust the practice to any project or customer that is to their specific needs. There is an agentic execution platform which, basically runs everything and provides set of capabilities like state and memory management, integration with tools. We use MCPs here. We built some of the MCPs. We use other available MCP servers, and tools. So any tools related to making this workflow this orchestration be possible. So we run everything in containers, and internally we run it, since we are a partner of Red Hat, internally we run it on OpenShift. Of course, it's containerized, so it could run on any platform, but we run it on OpenShift, since also OpenShift comes with a lot of pre-built capabilities that could be used. But I will let Marek talk about it later on. Yeah, so this is PractIQ today, and yeah, we are introducing it to the market, and the road ahead is what we are working on is now we use it mainly for new software, like building new components, and we are working on also the modernization practices. So basically building a practice to take the old source code and transform it in a way that it could be done in agentic mode. So we've already have some experience with some technologies. We're working on the new ones. Yeah, practice engineering, reverse engineering of existing code bases. That's also interesting. That basically you have code bases which are, I would say, legacy or not maintained, and we would like to be able to actually understand what is there and build it with new approach using AI. And one of the most interesting thing is the practice engineering part, which is what if you could just deliver an AI workflow, the practice that guides you through solving any given problem. So basically producing new practices for any given problem, not only in, I would say, software delivery, but also in other domains like business domains, like agreement scanning, customer claims, any problem. So that's really quite exciting. Yeah, so that's what we are working on. And yeah, today we would like just to tell our story. We told you our story. We'd like to also hear about your challenges. Where are you now today? On your road with AI. Yeah, and I would like to invite you to learn more about our platform. You could access our websites, inteca.com and practic.tech, and of course feel free to contact us. There are my email. You had my email here, and there are contact forums and emails on our pages. Yeah, so that's it. Please feel free to ask questions on the platform. We will have the Q&A session after Marek's session. So that's all from me. I would like to pass now to Marek, and over to Marek. And do we have Marek on? Yeah, I see Marek now.
Yes, we have.
I'll stop sharing now, and Marek, the floor is yours.
All right, thank you so much. It's really mind-blowing for me because, well, it's kind of a clear and understood for me, and that approach to start from the intent, put it on top of the domain, then apply the practice to that to achieve the ready-to-use product is really something which actually I never seen such approach as a, say, inside one product even. Right. All right. Let me start with a couple of slides of my presentation now. Could you guys confirm that my screen is visible correctly?
Yes, we can see it.
Right. Thank you so much. Let me tell now and switch a little bit to the Red Hat story and why the Red Hat is at the AI space, which is I wouldn't say that this is a very long story, but we are in interest of let's say data analytics and the data outcomes on top of the application platforms for years now. Yes, some of you, if you just follow the products that we are delivering as Red Hat, you might see first of all the open source project, which is called Open Data Hub, yes, where the story begins, And now that story has shifted a little bit towards the AI, because we see the value of the AI, we see not only the popularity, but the power of an AI in many spaces. Yes, so that's a very fast evolving thing. I mean, AI, especially because of the fact that each and every day, possibly we will have more and more, say, use cases where the AI can help us with, right? We started from the very simple reasoning, but then we got to the agentic AI, to the, say, LLMs we have now. And again, as I said, each and every day brings us more value and more use cases in really different spaces. All right, let me just briefly start from why the open hybrid platform, right? Why the hybrid platforms are or could be important for our customers in the space of an AI, right? So first of all, in Red Hat, we believe that the cloud is hybrid, right? So we are trying to cut a little bit on the infrastructure layer to make the kind of abstraction layer above it. And we believe that the application platforms are the perfect products and the perfect solutions and the way of thinking and sometimes the strategy of our customers to deliver efficiently the software, right? So this middle part, so the infrastructure, we believe that the open application platforms help the customers to abstract the infrastructure to deliver the application and then boost the development and all the IT processes which are connected to the not only the development process, but also the application delivery process and day two operations, which are connected then to the process of exploiting the platforms, the applications. All right. So that comes to the product profile, which is called Red Hat OpenShift. Some of you may know it. This is very important piece of a software in the infrastructure for our customers because the applications lies above it, right? So for some of our customers, even each application has been delivered through the application platform, which is Red Hat OpenShift, right? That, of course, can bring various types of the applications. The best would be the cloud-native applications. So what I mean saying that? The cloud-native applications are the applications constructed using the principles of how the cloud works, right? How the cloud operates the applications and accompanying services, but also the traditional applications could be brought to the application platforms in most of the cases, right? So, but then it comes to the AI and machine learning, say functions and the deliverables, right? Which are combining various processes at our organization, right? So, but the end of the day, the AI for us is another workload, right? It could be specific, it could be demanding, it could be a little bit different from what we know from the cloud native and the traditional applications, but still it's workloads which we believe perfectly fits to the application platform. Yes, so the application platform story is a kind of a long, yes, and if you observe, for example, the left-hand side of the visual, the year 2010, the Red Hat begins to invest and carefully overlook the application platforms market to come up to the stage with the products which is still now known as an OpenShift application platform, right? So as you see, that was even before the Kubernetes came to the stage. The Kubernetes is, I believe, one of the most important elements of the applications platform because it provides many mechanisms which are, say, obligatory for the application platform, supporting day 1 and 2 operations. Yes, now we are at the year 2025, soon 2026. So we spent more than 15 years developing and improving that platform. And this is the totally different based from what we know from the past. Yes, now we are able to support the customer workloads of pretty much whatever kind, AI inclusive, right? So we also believe that three main say obligatory points should to be delivered by the application platform. First of all, it should to be trusted, yes, because the customer needs that, yes. Then it should to be comprehensive, and this is our aim, to provide the customers the full-fledged application platform consists of each and every required element, which sometimes the customers doesn't know from the very beginning, from the start of the process to implement the application platform, that it will be any handsome or any available at the platform. Yes, and then it should to be consistent. Yes, again, being back to the cloud native applications and cloud native as a trajectory, the consistency is needed to don't build, the different stories for the different infrastructure approaches, right? So what I mean by that, yes, the trusted, yes, in Red Hat is kind of easy for us to make it trusted because we are governing that ground up. So whatever the infrastructure is underneath, is it the public cloud, is it the bare metal, is it the virtualization, or whatever kind of the infrastructure the customers are using internally or as a hosted stuff, or whatever kind of a delivery we can imagine, we are putting the operating system we are famous through, and then on top of the operating system is easy to build another layer together with the application platform, and then the trusted content delivery, because it's becoming more and more important at nowadays. Yes, because security, for example, proves that the delivery process of applications are the attack surface of the, say, attackers nowadays. Yes, because we are pretty much safe on the operating system level, because we are managing that for years now. So we know how the attackers approach the operating system. So it's I would not say easy, but it's quite a known thing how to support that security posture. Then the OpenShift, like a Kubernetes, again, the Kubernetes is known for 10 years. So we know how the Kubernetes could be vulnerable, how the Kubernetes could be attacked, and so on and so forth. But then, if it comes to the applications, the surface differs from customer to customer, and then from the, say, method of building it to the method. Yes, so that surface is larger and larger, and not opposite. Yeah, comprehensive, again. We are focusing on to deliver pretty much full tool set on our application platform, which is the OpenShift, to provide the customers with for example, the CI/CD processing, to support the delivery process. Yes, the development tools, together with the application services like I know, the databases or the streaming services, the connectivity, security, registry, whatever you can imagine and ask for. If we don't have that at our portfolio, possibly, and 99% sure that our partners are delivering what we don't have and what we are not focusing. So then comprehensiveness of the platform is quite important for us at the moment. And then consistency. Again, as I said, we see the OpenShift as an abstraction layer. Whatever the infrastructure is, the OpenShift is still the same. So all the processes worked out throughout the, say, development and the delivery will work regardless the platform from the infrastructure standpoint is, right? So this is our aim. This is the like a sentence. The OpenShift is an OpenShift is an OpenShift. So whatever implementation of an OpenShift we can imagine and have, still the consistency is the focus. To don't change the code because we changed the infrastructure. All right. Again, then it comes to the AI, and we believe that pretty much the same process applies, right? So, like tuning lifecycle and then serving is a like a step-by-step implementation phases of an AI. Again, being back to my entry sentence, that AI for us is yet another workload on the application platform. That helps us, and we are just building on top of our legacy, because it makes no sense to deliver and develop the special mechanisms because this is AI, right? Again, AI is an application like any other. And finally, it takes us to the place where we are now. Yes, the year 2025 proves again that we are leading that market, and the market is important, but also for us at Red Hat is pretty much important that what we do is right. Yes, the approach is right, and if we have for like a consecutive years the right approach, we believe that throughout the another years we just keep the trajectory, and that's our aim finally. So basically, aim of ours in the, say, Red Hat AI, I do not mention here the say products, yes, because the product naming is a changing thing, but the set of the products and the ideas in Red Hat is called just simply Red Hat AI, and our aim is just to provide the trusted, consistent, and comprehensive foundation, yes, whatever the accelerator is and whatever the, say, elements of the clouds are, right? And this is possibly it. About the products, yes. So you may see the names of them at that slide. So from the right-hand side of mine, yeah, the Red Hat OpenShift AI, full-fledged platform, the AI platform built on top of the OpenShift. Then for the customers which are not maybe ready or still at the exploratory, say, single box phase of the experiments, we deliver as part of the regular Red Hat Enterprise Linux, the Red Hat Enterprise Linux AI, with all the tool set required to train, operate, and serve the model. And then even on the other platforms, which are not basically Red Hat platforms, I mean, not OpenShift, not RHEL, the inference server, which is kind of a native mechanism to serve the models on any other Linux distributions or any other Kubernetes that are at the market. Again, and this is all, of course, available throughout the open source, right? So our product's evolving. If you check, for example, like a sentence, Red Hat AI version 3, or just simply Red Hat AI 3, you will see what we do as new things. Yes, what we use, what kind of products and the projects were involved into the third generation of our AI platform, just to support this, again, comprehensive set of the tooling and the functionalities which are built first of all on the OpenShift, and then serving the AI models for the applications and all the machinery which is AI connected at the customer side. Yes. Then let's talk about the say business. Yes, because you may see the MIT report, which is elaborating about the Gen AI state in the year of 2025. Yes. Which shows maybe surprising numbers. Yes, because the customers, the majority of the customers are reporting that they did not achieve the business goals according to the implementation of an AI-driven projects. Yes, so that make me think: is it anything wrong with an AI, and it's still under the discussion, or AI is over expected by the customers, right? So that's why we see like a three basic silo where the expectations are. Some people, for example, expect the revenue growth, revenue generation measured in the money, measured in the simple sell or better margin, and they are expecting the AI to help them with that. Yes, the others could benefit from the cost optimization through an automation, through supporting the processes which are, say, native for the organizations, and support them the different way thanks to the AI. And finally, for example, the risk management. Yeah, so still we can discuss: is it the fail of an AI as a tool, or is it the fail of a human or the organization to to position and define the business drivers correctly. Yeah. Okay, and now it's time to the question and answers, I believe. So I stop sharing now, and we will elaborate much more then.
Okay. So we got some questions. Mark, since maybe you would like to be the first to answer some questions.
Okay, happy.
Yeah. Okay, I'm trying to see which of the questions would be for you.
Right.
Does OpenShift support any native auto-scaling mechanism for AI models that, experience when you experience sudden spikes in computational demand?
Yeah, that's a quite important question. Yes, because auto scaling maybe not necessarily, but usually it's connected to the cost. Yeah, so we support the auto scaling the same for the AI workloads, the same way we do for any other workloads which are available at the OpenShift. Yes. You may know the term which is called the serverless. Yes, and the serverless is a mechanism which is specially designed to work on the, say, Kubernetes, and then on the application platforms, to support the workloads which are unpredictable, first of all, and then the workloads which must, for some part of the time, work at the, say, zero consumption. Yes, which is kind of an anti-pattern if you overlook the Kubernetes. Yes, because the Kubernetes is designed this way to survive with a working pod, for example, each and every point in time, right? Because if you deliver something on the Kubernetes, Kubernetes surrender that workload each and every time you're trying to kill it, or anything which is reacted with the spot is trying to survive the spot. And the serverless is a mechanism which delivers, we call it scale to zero paradigm. And for the OpenAI, for the AI we do the same, and we support the same well-known mechanism which is called serverless. That's from me.
Okay, so maybe another question mark for you, because also interesting one regarding performance. Are there any performance differences between running AI inference in containers on OpenShift versus on bare metal? Do you have any benchmarks or observations?
Yeah, and that needs a little bit of an explanation, yes, because the word performance is quite of a wide definition. Yes, the performance we know from say the computing systems we know at the moment. Yes, so all measures like TPMs, transaction per minute, the IOPS, whatever performance metrics which applies to the say well-known systems not necessarily apply to the AI, yes, because at the AI measurement, we are using the totally different metrics, like, for example, time to first prompt, yes, once you're asking the question to an AI, say, model, you are expecting the first prompt to be displayed or delivered at the given point in time, yes, and this is kind of a measure of a model performance. Then there is of course, the full answer, so like a time to the last line that the model is producing as an output, and there are the measures of a performance at the AI world. So we cannot compare them what we know from the past, yes, but yes, we do have the observability as such is a part of the, say, OpenShift AI platform from the very beginning, yes, because we understand that this is important for customer to figure out and measure how efficient is an infrastructure, how efficient is a model itself, yes. Together with that, we provide the tools to optimize the models, because again, the model as a kind of a, say, binary kind of a beast could be optimized, yes. And I don't want to elaborate about the methods, yes, because I'm not a specialist on it. But again, what we need to understand is as part of the AI serving platform, the model efficiency tooling is a must to have as a toolbox, right? Then there are the different factors which are connected to the accelerators, right? Because if we don't fulfill the requirements, for example, if I can get an example here, right? If I can bring example, like we are using the two large models which do not fit to our accelerators memory, yes, because how the accelerator works. Each and every time accelerator reads the model and tries to put them into the memory of an accelerators, yes. If not on a one host, which is possible on the OpenShift, just to use a set of hosts to fit the model. And of course, if we overachieve the expectation from a model, which is large, and we have the infrastructure, which is just small to fit in the model, we cannot expect performance. So again, this is the very wide topic, and what I said at the beginning, we cannot measure the AI performance the same way we used to do with well-known systems till now.
Okay, so thank you, Marek, for this answer. We have one more interesting question. I guess it will be for me. How does the platform differ from other AI tools for developers? That's kind of interesting. We have this when we also show it to customers. We are asked this question, and sometimes we have these discussions that a customer says, "Well, I took Cursor and opened our code base, and it didn't work. Well, it didn't implement or it's, well, basically didn't go in the right path. So basically the problem, and now everybody is talking about, well, how to use these agentic tools, I would say AI tools for coding, and there is a lot of discussions about what is being called now spec-driven development. So basically, the industry is now in a position where we understand that AI needs guidance, needs specification to do the job properly. And well, that's how we try to differ, because we started this very early, and our observation was quite obvious that, well, we need to start with this proper guidance from the very beginning. So I would say the difference is that we try to cover the full scope of SDLC, starting from the actual business requirement, and then understanding the context, the large context of the enterprise. So understanding also the architecture, what systems are there, what capabilities are there, what is the actual architecture. So we work a lot of our customers, well, actually with architecture teams and analysis teams as well. So we understand how the problems they face. So our approach is to basically start solving this problem very early in the enterprise, not only on the source code base in developers, but basically start this solving this problem very early. So in a spec-driven development, that there is a concept of build the spec and agent will do the job. Now the good question is, the right question is, how do you build the spec using AI? That's an interesting question. How would you use AI to provide the right spec? And then what is required there to do that? And that was the initial question we wanted to answer. That was our focus from the very beginning. So I would say the coverage of the process, what parts of the process we cover, that's, I would say, the main difference. And that's the reason the main difference, and the thing that we actually start very early in the process and support the process from the very beginning. I would say that is the main difference. And the second one would be, I think you get an actual framework for constructing practices. So we thought a lot of things on our way, and we solved a lot of things, and think there are like repeatable patterns that we already have. And basically, we just this is something that basically allows to extend what we already have, like available practices we have for certain technologies like Java, Angular, design, architectures, but we could also build new ones using the same approach. So that's also the differentiator, in my opinion. Okay, and I think that will be the last one from me. Yeah, we had this from Marek. Yeah, I see. Yeah, our platform already available for customers? Do you have a demo? Can it be tested in any way? Well, yes, we have. Well, we don't share it publicly yet, but we do demos for our customers, and we take first proof of concept with our customers. So basically, trying to replicate what we do internally on customer actual use cases, actual problems, but we do it on the like individual customer cases. So that's our approach for now. Okay, I think I don't see any more questions.
May I have one?
Sure.
Okay, so because it's kind of interesting for me, yes, from your experience, and from the kind of a perspective of the quality of a final product, what is more important? Is it a better define a say intent, or is the better practice?
Well, the thing is, the practice steers the intent evolution. So if we see that, okay. So it's like, so simple answer is practice, because if you have a good practice and the intent is not really clear, the agent will ask you the questions and detail the intent, okay? Because it will not pass the checklist for whether we are understanding what we are planning to build, right? So definitely the practice part is the most important, because if you get it right, the workflow will make sure the intent is specific and it's testable, so we can verify that we understand it, right?
Okay, so just maybe another one. So the intent is not like something which is done at the very beginning, yes, and it's all fixed, yes, and so you are evaluating the intent throughout the practice, and the practice is leading a little bit and is steering a little bit how the content should look like finally, right? Am I
Yeah. That's Since I showed on the demo, I showed the use case driven approach. So the use case require a proper this like there is the practice delivers definition of what a use case is, and so if we cannot determine what the functionality is, we need to detail the actual requirements. So the demo was showing like a general business requirements coming in, and our experience is that customers, they will throw a lot of different stuff at you, like business requirements mixed with functional ones, with performance. So the whole idea of this first step of the process is that you basically try to build a graph of what actually we're dealing with. So try to make like classification of this intent and put it in a requirements model, which is like more structured approach. Then for the next agent to take over, and then going one by one and splitting it into more detailed designs, like what is a use case, what is actually a step maybe in the use case, what is a validation rule maybe in what is actually the data requirement. The actual intent is to show some data on the screen or store some data in some sort of system, right? So this is actually how we capture the intent. We basically build like a knowledge graph, requirements graph of what was actually initially put in on paper or put in any conversation we have with the customer, right?
Okay, thank you so much. It's pretty interesting, yes, because I'm observing what usually the people are trying to to deliver software in say one way, like we know from the CI/CD or the pipeline, right? Yeah. So you pass the pipeline, you're done, you've got your product, yes. And I see that the practice, at least of what you're saying, and this is not our first meeting, so I'm starting maybe to understand. You can correct me if I'm wrong. That the practice as product is designed to be, say, iterative from its nature. Yeah, that's what I understand.
Yeah, and that's basically the whole idea of orchestration. That's the key, right? So you need to, and this is the way we work as humans, right? We do it iteratively. We do something, we check if it's valid, and we get back to like if the assumption changed or it doesn't pass the validation. Our ways of working are like iterative and collaborative. So we collaborate as people, as humans, right? So now the whole idea is how do you make these agents collaborate, not only with go through the workflow and collaborate with themselves, but also collaborate with people, and what's actually the role of people in the whole process. And today it's obvious for us that people are drivers, right? Like have a leading, let's say, role in the whole approach. But since I also told that some of the checks are being done by agents, so one of the agents is checking the job of another one, so we are also getting there, right? So that's quite exciting, I would say.
Yeah. We are observing, because from the very beginning, the people tend to think that they are communicating with one model only just to get an answer, and that answer is correct, yes. But effectively, this is kind of a practice which is called model chaining, right? So once the models are communicating with other models, just formalize the, say, final question that is been asked to an arbiter model, which delivers the final output. That's very interesting. Thank you so much for clarifying the practice for me. Really appreciate
the question too. Thank you. So I think I'm not seeing any more questions from our audience. So, and we are approaching actually end of our time as well. So once again, thank you for joining us today. Marek, thank you for your presentation, and it was a pleasure to host it with you today.
Thank you so much. Anytime.
And yeah, thank you, and I hope to see you maybe on the next one we're gonna host. Thanks.